So, greetings for the day to all of you, and I welcome you all on the next class of software engineering. And the topic for today is function oriented design. So, today's topic that I am going to present on a software engineering is function oriented design. So, in my last presentation, we covered the basics of software design, and we just touched the two approaches of software design. One was the function oriented design and another was the object oriented design. So today I will present the whole lecture on the function oriented design. So I made the presentation for this. So let's have a look on this presentation. So this is the organization of lecture. First, I will introduce what is function oriented design. Then I will cover the topic of structured analysis and structured design. Then we will do the data flow diagrams, some examples of implementation of data flow diagrams and the summary. Next. So function oriented design techniques are very popular because I said any project which is in our hand, we can make the design of that project. The phase of designing can be done with the two approaches. One is the function oriented and another is the object oriented approach. In function oriented approach, the whole project is considered as we divide the project into the small modules. So function oriented design, it starts with the functional requirements specified in the SRS document. Whatever the functional requirement that we specify in the SRS document, in designing phase, we implement all those requirements. Whatever the need is there from the project, that is implemented in the design phase. Next. So during the design process, first of all, what is the first step? It is the high level, then the low level designing. In high level designing, what happens, or the preliminary designing, we identify the high level functions that will be part of our project. So main functionary, all the things as we did in the library management system. The main function of the library management system is to make the membership, then issue the books and return of the books. These are the main function of the library management function system. So high level functions are first of all, they are identified. Then we are going for a modular designing. Modular approach is there. So it is further decomposed into the detailed functions. So that is the modularity. So finally, the detailed functions, that the detailed modules that we have generated, they are mapped to the module structure. So function is divided into the sub function, and each sub function part becomes the part of the module, or the one modularity approach is there. So it becomes part, or it is mapped to the one module. So successive decomposition of high level function is done into more detailed functions. Technically, this term is known as top down decomposition, and the concept is known as modularity. So here what is done basically, it is this methodology is known as SASD methodology, that is structured analysis and structured design. So this methodology comprises of two steps. One is the structured analysis and second is the structured design. So how this comes into action, what is the meaning of structured analysis and what is structured design? Let us see now. Next. So SASD methodology consists of two distinct activities. One is the structured analysis and second is the structured design. So during structured analysis, this functional decomposition takes place. That we have done that in the modularity approach. So we decompose the modules in according to their functions. That is known as the functional decomposition. Then structured design is done, where we find out some programming language where it can be implemented. All the functions can be implemented. So in functional decomposition, so it is the hierarchical approach as hierarchically decomposed into more detailed functions, and simultaneously decomposition of high level data into more detailed data. So high level function is divided into the sub functions, and the data corresponding to these functions, the high level function and the sub function, that is also decomposed during this process. Next is what is done in structured analysis more, the transformation of textual problem description into the graphical model. And the graph which is used here for this purpose is known as the DFDs, that is data flow diagrams. So DFDs graphically represent the results of the structure analysis. So whatever the breakage of the whole project into the main functions, so those functions are represented in a DFD form, in a graphical form, which is known as DFDs. And if the main function is further divided into the sub function, that DFD is also taken into the next level and it depicts the sub function that we will do in a coming presentation. And what happens in structured design? So all the functions represented in the DFD, they are mapped to a module structure. So this is the main function of the structured designing, and therefore it is also known as software architecture. The module structure is also known as software architecture. So detailed design, which is also known as software architecture or the module structure, it is defined through the detailed design. It is a part of the detailed design. So structured analysis is not the detailed designing, it is the high level designing, but detailed designing comes under the structured designing. So it is therefore known as a detailed design because we redefine all the functions through the sub functions and their structure in a detailed design. So this is comparison between structure analysis and structure design. The purpose of structure analysis is to capture the detailed structure of the system as user views it. And the purpose of structure design, I'm just repeating again, it is to arrive at a form that is suitable for implementation in some programming language. So depicting, telling the user or depicting the whole thing the graphically, it comes under the DFD, which is part of the structure analysis, and implementation through some programming language, it comes under the structure design. So result of structured analysis can easily be understood even by ordinary customers. Like does not require computer knowledge. So ordinary customer does not require computer knowledge, directly represents customer perception of the problem in a graphical manner through the DFDs, and uses customers terminology for naming different functions and data. But the result of structured analysis can be reviewed by the customers also to check whether it captures all their functional requirements that were specified in a SRS document. So based on principles of top-down decomposition and the divide and conquer principle, which is the main factor of the modularity approach. So graphical representation is carried out in structure analysis, which is known as data flow diagrams. So it includes so basically also known as the bubble charts. We will see because all the processes, all the functions are represented by the bubbles. So coming to DFD, it is the main concept of the structure analysis. So DFD is an elegant modeling technique. It is useful not only to represent the result of the structure analysis, but it is applicable to other areas also, like for showing the flow of documents or item in the organization, how the control flows from one function to the another, how the data flow takes place. So the whole flow is depicted in a data flow diagram, how the data flows from one function to the another function. So DFD technique is very popular because it is very simple to understand and use. So it is a hierarchical graphical model. It shows the different functions. Functions means all the main things, all the processes of the project. Suppose I will just show you. So if there is any DFD now I'm doing, if any project P, so it is divided into function 1, function 2, function 3. So we define this function as a bubble. We represent these functions as a bubble, and from where data flows from one function to another, that is shown in a DFDs. So that we will do the detailed DFDs now in a coming slides. So it is useful to consider each function as a processing station. So in DFDs, each function is considered as the processing station. So we can give the name either as the process or the name of function, etc. Yes. So just simple diagram, just see here. Just wait for a minute. So just see the data flow model of a car assembly unit. So this diagram will give you the idea of all DFD. So main process of the first, what happens in the car assembly unit, we get the chassis first of all. Chassis is provided. So on this chassis, we assemble the different units of the car. So just start with this. So we have the chassis from the chassis store. We will get the chassis from the chassis store. So this symbol is represented to represent the data store. This symbol is known as data store that we will do in the coming slide also. From here, one store is chassis store. We will get one chassis. So first process on the chassis is fitting of engine. So, and from where we will get engine? We will get the engine from data engine store. So this is known as bubble. This is known as bubble, and it represents any function or process. Each bubble represents a function or a process. So here the first process is get the engine and fit it onto the chassis. So this is the first function in the car assembly unit. That function is shown as a process through the bubble. Then is fitting of the doors. So from where we will get the doors? So fitting doors. Doors we will get from another data store, that is door store. Okay. Then partly assembled car is there. Then we will fit the wheels. Wheels we will get from another data store, from the wheel store, and the fitting of wheels is carried out. Then paint and test, and final output car is there. So this is the function or any process which is represented by the bubble or the circle. It gets some input and finally it has some output also. So this is the output. This is the output of this function, and it gets some data on which it works. So data it gets from the data store. Even some function can give the data as the output, and output can be stored as a data on a data store. So this is the simplest, you can say, idea for the DFD, but there are many more concepts related to the DFDs, like naming of the DFDs, numbering of the bubbles. So that as some external entity is involved, that will be covered in the next slides. So a DFD model uses limited types of symbols. It is simple set of rules. It is easy to understand, and this model is a hierarchical model. So human mind can easily understand any hierarchical model. So it is very easy to understand any DFD through its representation. Next. So just see the hierarchy. So similar is the way of the DFDs are represented. The main function at the top, then function is divided into the sub function, and sub function can further be divided into more sub functions. That is the modularity approach is followed. And how we represent the processes, the sub functions and the functions in a DFD, that will be taken into the next slides. So this is just the simple example. Outside world is there. So short-term memory is there. We search something. Long-term memory is used from 1 million. So brain is there. So I will give you some more important example in the next slide for the DFD. So how does the human mind work? That is the digression. So short-term memory can hold up to 7 items. So in software engineering, the number 7 is called as the magic number. So an item is any set of relation involved. So this I am telling about. So what is the number of, you can say, bubbles we can represent? It can be from 0 to 7. Then it is good. Otherwise, it will be very cumbersome part. So coming to DFD, so primitive symbol used for constructing DFDs are rectangle, which is known as external entity. Then circle is the bubble, which is used to represent any process. Then this double line is used for the data store, and the arrow for the data flow. Next. So some external entity, just example, librarian. So in a library management system, a librarian is the external entity. So symbol used to represent a librarian is a rectangle. So any functionality, suppose search book is there. So it is one process, one function. So that function is represented as by the circle, which is known as bubble or process or transform. So whatever the work, any you can say in Hindi or Punjabi we say kriya, कुछ भी क्रिया we do, कुछ भी क्रिया यानी काम करना. So that काम करना is the function. So that function is represented, that process is represented by the bubble. So any, you can say, line or the arrow, it tells you about, it can be either the simple line or a directed arc, which is telling you the data flow symbol. That is what is the direction of flow of data from one unit to another or some one function to another. So data store, from where we get the data and from where we will store the data. So that unit is known as the data store, and the symbol for data store is double lines. So this is the data store symbol. Suppose find book function, and from where we will find the book, what will be the input from where we have to find a particular book. So data store, here the data store name is books. So it is the collection of books from where we have to find the particular book. So output produced by the system, it is represented by the inverted trapezium. Next. So synchronous operations. So if two bubbles are directly connected or two functions are directly connected by a data flow arrow, they are known as synchronous. So just see here, read numbers, validate numbers. We have data items, that is the input to any system. First function is shown by the bubble. The bubble is represented by the read numbers. Second function is shown by the bubble, which is known as validate numbers. So they are directly connected through the arrow, data flow arrow. Therefore, such operation is known as synchronous operation. Next. But if in between the two bubbles, if there is some data store, then means they are indirectly connected through the data store, then it is known as the asynchronous operation. So the notations that we would be following are closer to the Jordan's notations. So Jordan's give these notations. Next. initially, how is structure analysis performed now? So initially represent the software at the most abstract level, which is known as the context diagram. So what is basically the context diagram? Now listen here carefully. Suppose we have any one function. It is further divided into many two functions, and this function is further divided into these two functions. This is A, this is A1, A2, this is A11, A12. So this is first higher level function at the abstract level, which is known as the DFD level 0. It is denoted by the DFD level 0. Then here the name of function is suppose A. Now numbering is very important in DFD. So here the level it will be denoted as 0. It will be denoted as 0. Okay. And in the same level, some more functions are to be represented, like B is there, like C is there. All are the DFD become the part of DFD 0. So DFD at level 0 is known as context diagram. So suppose this is B and this is C. So here the numbering is very important. Naming is also, so it is the first functionality of any system and it is the higher level. Then this is connected to this is connected to this. So this is the DFD of level 0. And numbering will be 0, 1 and 2. Now suppose this function further is divided into the sub functions like A1 and A2. Clear? So this will represent the DFD at level 1. DFD at level 1. So DFD at level 0 is known as context diagram. DFD level 1, then level 2, then level 3, and higher level of DFDs are represented. So if we divide it like this and name it A1 or A2, but here you have to see that numbering is very important. So its number is 0. In the one level, the numbering will be 0.1. And second, the numbering will be 0.2. If B has further subfunctions and it will be represented in DFD level 2, then here numbering will be 1.1 and 1.2. Clear? And suppose here 0.1 is further divided into the subfunctions, it will be represented in at DFD level 2. So it is hierarchical also. So it is hierarchical also, but here numbering will be 0.1.1. Here it will be 0.1.2. So the numbering will be given. So if point is here dot dot dot, so if two dots are there, so in total 3 digits are there, so it is DFD level 2. This is DFD level 1. And if same numbering is given, the integer numbering is given without any decimal point, then it is DFD of level 0, which is also known as context diagram. So here I show the hierarchical nature of the structured analysis also. And numbering is very naming and numbering is very much important. For this, we will see in the more example, this labeling is very much important. Next. So it is a simple tic-tac-toe game you play. That is the cross and the circle. So the context diagram of DFD level 0 of tic-tac-toe, DFD level 0 of tic-tac-toe. So very important. So simple main functionality is we have to play the tic-tac-toe. The main functionality it is the tic-tac-toe software. So what it needs the external entity to play. So external entity is human player. It is denoted by rectangle, and the main functionality is represented by the bubble. So what human will go for a move and it will display. So this is the DFD of level 0, which is also known as context diagram. So DFD at level 0 is known as context diagram. So this is the context diagram of tic-tac-toe. We will further see level 1 and level 2 of this tic-tac-toe in our coming slides. Next. So a context diagram shows data input to the system, output data generated by the system, and the external entities. So context diagram captures various entities which are external to the system and interacting with the system. It also shows data flow occurring between the system and the external entities, like here. And the context diagram is also called zero level DFD or level 0 DFD. Just remember, context diagram is known as level 0 DFD. Next. So it establishes the context of the system. Therefore, it is known as context diagram, and it represents the data sources and the data sinks from where the data starts and where the data will end. So it is shown in a level 0 DFD, that is the context diagram. So level 1 DFD, how it is made? So first we examine the SRS document. We represent each high level function as a bubble, represent data input to every high level function, and represent the data output from every high level function. So if we want to make the level 0 DFD of any project, then we will go to the SRS, we will see the main functionality, and we will represent as a bubble. All the external entity we will represent as a rectangle. All the data needed we will represent as the data store, or direct data is given input, then it will be the data input, and output will be the data, final output will be the data output. So we have to look onto the SRS document first of all. So higher level DFDs, each high level function is separated, decomposed into sub function. So I told you that higher level DFDs are made from the previous level of their DFD. So from previous level, each bubble is decomposed further. That is known as factoring. That is known as dividing the bubble into the sub bubble, means dividing the functions into the sub function. So that is known as the factoring. So we identify the data input of each sub function also and data output of each sub function also, and these are represented through the DFDs. So decomposition, as I already told, decomposition of bubble is also known as factoring or exploding. As I did in the previous in the board when I was showing, A was there and we have factored A0 as 0.1 and 0.2. So this was the dividing the function into the sub function, and representation of that process is known as factoring or exploding. So each bubble is decomposed between 3 to 7 bubbles generally. Next. So if we have too many bubbles, then it is also problem. If we have very less bubbles, then also it is also problem. So more than 7 bubbles at any level of DFD, they are not, you can say, found good, you can say structuring. So it made DFD model hard to understand. So we will do one example, that is the RMS calculating software, and we will see this up to level 2, level 0 level, 1 level and 2 level of this. So understand what is the problem, then we will represent this problem through the DFD. So consider a software called RMS calculating software. It reads 3 integers in the range of -1000 to +1000. It finds out the root mean square of the 3 input numbers and displays the result. So I will stop here just for the minute and tell you on a board what is this. So we have to find the root mean square root. Root mean square of three integers, a square plus b square plus c square. Okay, and these integers a and b can be from range minus 1000 to plus 1000. So in this, we have to make sum also, we have to find the root also, and we have to find the mean also. And next is, if we enter any value in a variable a, then we have to validate also that number is between 1 is 1000 to 1 plus 1000. Similarly, if we enter any number in b, so we have to validate because the range is given. So here the main functions are getting the numbers and validating, making the squares, making the sums, and finding the square root. So these are the main functions of this software. So how we represent these all functions into the DFD form, let's see next. So first level, that is the level 0 DFD or the context diagram. Just see, compute root main square, the main function. This is level 0 DFD, so their numbering is 0. It needs one user who will supply the numbers A, B, C. User will input the data. Data input will be A, B, and C, that is the data items. This is 0 level DFD of RMS, computing RMS of three integers ranging between minus 1000 to plus 1000. And finally, output will be the result. So this is the context diagram or level 0 DFD of RMS calculating software. Clear? Now, here we have to compute RMS. Now, it is the level 0. The main thing is computing of the RMS. Now, it is further divided into the sub functions. So, that sub functions, we will denote these sub functions in a level 1 DFD. Next. So, see the level 1. So, what happens in compute? So, this is further exploded. This bubble is exploded and represented in a slide in front of you. Just see, this data items will here. Same, I will make the here. Just see. So in place of this bubble, what happens now? So I will explode that particular bubble as shown in a figure. So it will be first part, it is read the numbers. Read the numbers. Sub function. Sub function of the RMS software, read numbers. So it is sub first function. So it is level 1 DFD. So therefore it is known as 0.1. So it denotes the level 1. After point, we enter one number. This is numbering, how we number. Then at the same level also, at the same level only, the second sub function is once the numbers are read, then we have to validate the numbers also. So it is a second function, but of the same level. Validating the numbers means we have to see the numbers are between minus 1000 to plus 1000. Okay. Then after validating numbers, what we will do? We will compute RMS. Compute root mean square. So it is 0.3. Then after validating, error may be there. So if it is the error, then we have to display that the numbers are not validated. Clear? And if they are validated numbers, they will come to here. We will compute the RMS and RMS will be displayed. So we will display the RMS and that result will be given to the user. So see, the same bubble has been exploded into the 4 sub bubbles. So it becomes the level 1 DFD. Now we can further explore this one also, compute RMS. So here the main thing is we have entered the numbers and validated and computed. Now computation is not easy. In computation itself, we have to find the square, we have to find the product, we have to find the sum. Sorry, not product, we have to find the sum and we have to do the square root. So in computing also, 3 sub functions further are required. Like squaring the numbers, we have read the numbers, but we have to square. Then like from A, B, C, we have to make A square, B square and C square. Then we have to add them plus plus plus. Then we have to find the square root. So this can further be exploded. Now I will explode this one in the next slide. Yes. So how this thing is explored? So we can explode this diagram and we will go to the level 2 DFD. Okay. So valid numbers are there. We get the valid numbers. Then what will be done? I will make it little bit here, this side. So first, numbers are here. We will calculate the square sum. We will calculate the squared sum. So it is that bubble was 0.3. Now we are plotting the 0.3 bubble. So therefore naming as 0.3.1. So calculate the squared sum. It is in front of you. Then calculate the mean. That is mean. So it is number at 0.3.2. Then we find the mean square. Then we find the root. Then you find the root. Okay. Calculate root. Calculate it will be 0.3.3. So it is 0.3. The bubble 3 has been exploded. And it will find the RMS. So we go to the same thing and it will be displayed. So just see, we started from the main first bubble and we exploded the bubbles and we reached to the second level of the DFD. So it exclusively, the slide in front of you exclusively represented the this part, that is the second level DFD of 2. And from this numbering 0.3.1, we come to know it is the second. And which from the previous level, which bubble has been exploded? The bubble numbered 0.3 has been exploded. Clear? So thus we make the whole data flow diagram of any project of the system. Next. So further, this square, this further can be exploded. 0.3.1 is further exploded. So first it is finding the square of A, then it is finding the square of B, then it is finding the square of C, and then it is giving all the things for the summing. So this was squared sum. Squared sum. It is further exploded in the diagram in front of you in a slide. So 0.3.1.1, 1.2, 1.3. So first it is finding the squares, and in 0.3.1.4 it is finding the sum. So it is further exploded and it becomes the DFD of level 3. So we have done the same problem with the 4 levels of DFD. 0 level, level 1, level 2, level 3. So that is total 4 levels of the same problem, that is the RMS calculating software. Next. So this was the main example. So decomposition is never carried on up to the basic instruction level. So because we have to show the function not the instruction. So it has to be taken into the sub-function level only, not to the basic single instruction level. A bubble is not decomposed any further if it can be represented by a simple set of instructions. Next. Next comes the data dictionary. So a DFD is always accompanied by the data dictionary. So what is data dictionary? It is list of all the data items appearing in a DFD. So all the items that appear, all the data items, all the data items which appear in a DFD. So data dictionary consists of list of all the data items that appear in a DFD. So definition of all the composite data items in terms of their component data items. It also have all the data items along with the purpose of the data items. So what is the need of the data item? What is the definition? What is the purpose of the data item? That all is noted in the data dictionary. Next. So it is very important because it provides all engineers in a project with the standard terminology for all the data. A consistent vocabulary for data is used. It is very important. For data dictionary will provide the consistent vocabulary. So different engineers tend to use different terms. But if the data dictionary is present, so it will provide the common standard terminology for all the data items to all the different engineers. And it will restrict from any confusion. Next. So some computer software engineering tools are there. So it automatically generates the data dictionary from the given DFDs. Next. Next on the data definition. So composite data are defined in terms of primitive data items using the following operators. So different operators are used, like the symbol denotes composition. So 3 commas denotes the selection. Similarly, name represents 0 or more instance of name data. Equal to represents equivalence, and asterisk represents anything appearing within asterisk. Double asterisk is considered as a comment. So data definition. So symbols are used in a data definition. So there is the list of symbols, common used symbols. So data dictionary for a RMS software that we have just made. So this is the data dictionary you can show. It includes numbers, A as an integer, B as an integer, C as an integer. The message is input number, input number, input number. So this is the list of all the data dictionary of the problem we have done, that is the RMS software. Next. So balancing a DFD is very important. So data flowing into or out of a bubble, that is very important. It must match the data flows at the next level. So therefore, what I was saying, so I exploded the bubble in the same diagram. Therefore, for this reason, I exploded the bubble in the same diagram. Though in my presentation slide, I have given the another view that for every level, separate presentation, separate slide was given. For level 0, separate slide was given. For level 1, separate slide was given. For level 2, separate slide was given. But we have to see the balancing also. That is, whatever the number of items are coming into particular bubble in a previous DFD, same number of items as the input should be in the next level also. So therefore, I excluded that bubble so that the number of input to the previous bubble and this bubble remain the same. Actually, here it was a one main bubble of 0.3. So input to that was this number. So I replaced that with this next level of DFD. So number of input is same. See again, in the first level of DFD, the output was the result. So in a final, what is the level 3 also, the final output is the result. So this is known as the balancing of a DFD. So we have to take into account the balancing of the DFD. So it is very important concept. So we have to balance the DFDs also. Just stop. Balancing is very much important. We have to balance the DFD into the next level also. Next. So just see here, balancing the P1, P2 and P3. We exploded the P3. So in the previous, in the level 1, input to P3 is C and output to P3 is D and E. So we have taken the P3 and exploded it into P3.1, 3.2 and 3.3. So input C becomes input at 3.1. See here, and there was also one input in the previous level, that is C. But in the previous level, P3 had two outputs. One was D and another was E. So coming into level 2, so D is coming from P3.2 and E is coming out from P3.3. So same. So this is known as the balancing of a DFDs, that to any bubble, the number of inputs and number of outputs should be balanced into next level also. So numbering of bubbles is very important, that I have already done. That is number the bubbles in a DFDs. So we start with the 0 level. The bubble is denoted by 0. For the next level, it is denoted by 0.1. For the further level, it is 0.1.1 and so on. Next. So tic-tac-toe game is there. So we will do the DFD of the tic-tac-toe game. You know about the tic-tac-toe game. A human player and the computer make the alternate moves. 3x3 square. A move consists of marking of the unmarked square. The user input between any cross or circle in any square between numbered squared numbered between 1 to 9. So it is the alternate move. So let's make the DFD of tic-tac-toe game. Next. This is the level 0 DFD, tic-tac-toe software. External entity human is needed. It will play the move and final output is displayed. Take it to the next level, that is the level 1. We will explore the bubble number 0, that is the tic-tac-toe software. So that bubble is exploded into 4 more bubbles. 0.1 display board, 0.2 validate move, 0.3 play move, and 0.4 check the winner. And the data store here is the board on which we are playing. So 0 bubble is exploded into 0.1, 0.2, 0.3 and 0.4. So main function is exploded into 4 sub functions. So number previous slide, just back, one back. So here also move and display are the, move is the input and display is the output. Just see here, next level. So just see, move is the input and result, that is display, is also the one output from the display. Next. So data dictionary for this is display, move, board, game and result. Next. So overall summary of what we did today, we have touched the first designing approach, that is the function oriented designing approach. Here we did what is structure analysis, and in structure analysis we did the DFDs, and structure design, it is the next, you can say, detailed design, where the design is implemented through some programming language. So it consisted of 2 parts basically, structured analysis and the structured design. So this is all in a software, you can say, function oriented design.